Um, so this webinar will be recorded, and we'll put this on our website. We'll circulate it to attendees as well. So if you want to come back at a later point and see it, and the presentation will be there as well. So yeah, so if you don't get anything, you'll be able to come back and watch it. Or if you've got colleagues or people you work with that you think would benefit from this, then you'll be able to share it with them. So a bit of background to this. The project, the service that we're running, People Powered Retrofit, is a collaboration between Carbon Corp and Urbed. Marianne, are you there? You're on mute. Yes.
Yeah, I'm here. Sorry, I wasn't hiding.
No. So Carbon Corp, we're a community energy organisation based in Greater Manchester, not for profit, and we help people in the Greater Manchester area and beyond to retrofit their homes to very high standards of energy efficiency. And we work very closely with Marianne and Urbed. So do you want to say hello?
Yeah, so I'm Marianne. I work at Urbed as an architect, specialising in retrofit, looking at some of the technical challenges, but also some of the kind of logistical and procurement and that kind of thing as well, which is what People Powered Retrofit is all about, really helping people overcome some of those challenges.
Yeah. Where to start? One thing to flag quickly is that it's Community Energy Fortnight here in the UK. So, and we're a partner in that. And yeah, this webinar is kind of part of our engagement and activity this time. We're also members of Cooperatives UK and the AECB, Association of Environmentally Conscious Building. And we're very valued members of those networks, and they give us tremendous amount of support, and we share information knowledge with them. People Powered Retrofit is our end-to-end service for householders who are looking to retrofit their home. And we offer a service right from advice and assessment through to on-site supervision, procurement, quality assurance. And heat pumps are becoming increasingly more part of that, an element that people are asking for, an element that we're procuring people to design on our behalf. That project, the People Powered Retrofit project, is one of BEIS, the Department of Business, Energy and Industrial Strategy, one of BEIS's retrofit supply chain pilots going on in the UK at the moment to try and create local markets for retrofit. And last year, in the research and development phase of us putting together that service, which is now running, piloting the service. But last year we visited a few places. We went to Scotland, but we also went to Ireland, and we visited Paul and his team in Tipperary in the middle of Ireland. And we got to see some of the projects that they're involved with and delivering, and see some of the fantastic work they're doing. It was just so much packed into a couple of days. There was so much experience, expertise there, and we've always since then wanted to share that expertise with more people in the UK and beyond, hence this webinar. Do you want to say anything, Marianne, about that visit?
Well, I suppose it's kind of interesting in the context of heat pumps and where things stand in the UK at the moment. The supply chain is still what you'd probably call underdeveloped. And one of the really encouraging things about going to see the work being done by Tipperary Energy Agency and Paul and his team was that they're installing heat pumps and they're working, and they're doing multiple ones. It's not just one that's worked, they've done multiple houses. So that was really encouraging, and yeah, kind of helping to shift what's possible when we're looking at non-fossil fueled heating systems.
And we really appreciate the data there. It's such a key aspect of evaluating and understanding how effectively heat pumps are working. Just a little bit on our position with heat pumps. I think until we went to Ireland and saw the installations at scale, we were very dubious about heat pumps, not necessarily as a technology per se, but in the way that they've been spec'd and installed and rolled out in the UK. And indeed, some of our work in Greater Manchester, we've seen some particularly very poor installations. And so, we were very sceptical. And now, having gone to Ireland, and also things are progressing in this sector really quickly, really. in terms of heat pumps and how viable they're seen as. We're very much changing our opinion. And I guess we're thinking about having a bit of a policy across people powered retrofit, but it's not something we have at the moment. Would you say, Marianne? What would you?
Yeah, it's well, so it links to the whole position around zero carbon homes and what it actually means, and the standards that we have to achieve, which I would say we're developing a position on at the moment, and we're doing a bit of research and thinking about it, but we don't have a fixed view at the moment.
But we're certainly influenced by what we saw in Ireland.
Yeah.
Okay.
Yeah, as you said, the data is the key thing as well, because people can make all kinds of claims, but if you don't see it in reality, it's kind of hard to believe.
So I will, without further ado, hand over to Paul. So Paul's the chief exec of Tipperary Energy Agency, and they run a program called Superhomes, not to be confused with the UK version. And so, Paul, yeah, take it away.
Very good. Thank you very much, Jonathan and Marianne. It's great to see and hear, I suppose, some good feedback from various different things. We've had a lot of different tours and visits to the Tipperary, and the first, I suppose, slide I have there on front of you is one that happened a little bit before the team from Carbon Co-op came, and what you see in front of you there is the membership of our part of the membership of our climate committee of our parliament, our Dáil in Ireland, and they were putting together a cross-party report on how Ireland can change the game from a climate change point of view. And we invited them down to Tipperary, and we brought them to a school which has undergone exactly the same type of renovation as we're going to talk about today. And you know, that was the TDs, the MPs as you would know them, but TDs, Teachtarálas in Irish, and they were standing in front of those heat pumps saying, I'd never seen one of these. This just looks normal. Why don't we just do it? So one of the things that's really important for any people out there trying to change the conversation around heat pumps is people need to see, believe, you know, understand the data for any new technology. And like heat pumps are a technology that isn't new. They aren't new, but we do need to make sure that people understand how they're applied in domestic homes. So in terms of the agenda today, I have a few minutes. I'm not really going to talk about why we want to go with heat pumps. I think everyone knows gas is a fossil fuel and we need to stop using it. We have about 10 years to cut it in half, and a lot of people would argue that we need to be at net zero for heat and electricity by 2040. So we know we need to get rid of fossil fuels out of our buildings, and that's the UK, it's Ireland, it's Europe, it's the world. So, you know, it's very clear in my head that's why. I'll give you a quick slide on ourselves. And then really, I'm just going to try and develop, I suppose, the understanding of how we've applied heat pumps to Irish homes. So a little bit of a reminder of the fundamentals. I'm sorry if that's boring for some people. But just it'll catch them, because I know there are some people who may be new to heat pumps on the call. We'll give a little bit of our approach from design to warm home, a little bit how we do that, how the results we've got. I'm going to talk a little bit around optimization and talk about some myths that are often used to say that heat pumps don't work, and they're often promoted by people who either A, don't know how to install the technology, like a plumber, someone who's heard of something from another unsatisfied customer, or more or less the gas and oil industry trying to tell us all that we shouldn't change from their wonderful product.
Paul, apologies, I didn't do the poll around who's in the room. Should I do that now? And it might help just to see the level of
that would be great.
Sorry about that. It's my fault rather. So we've just got a quick poll here. Who's in the room? Because I know, having looked at the RSVPs, we have quite a diverse range of people from across the industry and the householders as well. So if you'd just like to indicate where you're from, what your background is, that'd be great. You can tick more than one thing if you feel you don't want to be in one particular box. Yeah. Slightly regretting putting the other box in here now. Okay, I will end the poll there. So you can see we've got a range of people. We've got a lot of people in the other box. Maybe you could use the chat to tell me to tell us what the other bit is. But we've got some policymakers, some suppliers, designer architects, and some householders. I've now got just one quick poll, which is what's your level of knowledge? Where are you coming to heat pumps from? Do you know, you're starting with a base level of, you know, a lot, or it's just very new to you, or you know something and you want to know a bit more? I'm noticing no one's using no one's going to fess up to being an expert. Okay, I'll share these results. Should be able to see those. So yeah, so most people know a bit about heat pumps, some know a lot. No one's going to fess up to being an expert, and no one knows nothing. So that's something. Okay, sorry about that, Paul. Do carry on.
No problem at all. It's good to see some building services engineers as well, because one of the things that I think is really important to know, that building services engineers, and I'm not one, but I do employ about 10 of them, they are going to lead the transition for buildings. And it's really important that building services engineers across Europe really get stuck into decarbonising their heating systems. So look, I'll take a step back. The energy agency, I see there's a couple of other energy agencies on the call, and we've worked with some of them in the past across Europe. So the energy agency was set up 22 years ago as part of a European program. We have 30 staff, a lot of engineers, some communication staff, some scientists, and so on. We've a voluntary board, and we're set up essentially as a voluntary organisation underneath our local authority, which is called Tipperary County Council. So we're a non-profit social enterprise, and we reinvest profit that we make in developing solutions and communications around. Some of the brands we have are on the right. We do a lot of local authority energy management. About 40 or 45% of our work is in non-residential, I'd say, like kind of commercial and public buildings. We do a lot of homes through Superhomes. I'll talk about that in a moment. We work a lot in the community energy sphere, particularly with an organisation called Community Power, which just won a big European award yesterday under EU Sustainable Energy Week for a community virtual power plant. So we do a lot of that sort of thing. And we work a lot on promoting climate action and energy transition action in agriculture, in buildings, and certainly at a policy level. And I spend a reasonable amount of my personal time with officials and politicians. So that's the agency in a nutshell, some of our brands on the right-hand side. And really what we're going to talk about today is one of them, which is called Superhomes. We have about 265 homes that are retrofitted so far. Our retrofits include, I'll talk about these, a heat pump is part of every single one of those, and they work very well, and we don't have any complaints. Well, we always have a few little snags to finish with, contractors not doing everything perfectly, but we really are getting high performance out of our heat pumps. So just a little reminder on heat sources and sinks, because it's fundamental to making sure that we understand how to install heat pumps really well. So you may know that a heat pump moves heat from cold to hot, which is the opposite of the normal flow of heat from hot to cold. You use 1 unit of energy, and I'm really going to focus in on air source heat pumps. There are obviously thermal driven heat pumps. Anyone who has a camper van knows how they work. But generally speaking, you use 1 unit of heat to move 2 to 4 units of heat the ambient air outside to a higher temperature inside in the water in your radiators or on the floor. And really the fundamental design thing that you really need to understand is the lower the temperature difference between source and sink, the lower the work required to move each unit of heat. So that means the lower the temperature in your water in your radiators, your hot water tank, the higher the performance of your heat pump and the nearer the ambient temperature. So in the same heat pump installed in the same way in northern Scotland would perform obviously a lot lower performance than in southern England, just on the basis that the outdoor ambient air temperature is higher. And really if you take a rule of thumb, it's about 2.5 to 3% lower performance per degree difference on average over the 12 months. So in practice, how is that achieved? How do we harness that, the laws of physics there? Lower water temperature in your rads or tighter pipe spacing, 150 or 100 mil pipe spacing and underfloor heating. You achieve it by increasing the heat transfer area in the radiator, so i.e. a bigger radiator. And you achieve it by ensuring that the operational temperature time of that heating system is on. So it's not on for 2 hours in the morning and 2 hours in the evening like an oil or gas boiler might be, but it's on constantly during the day. And as the temperature drops outside to 3 degrees, 2 degrees, 1 degree, you try and run your heat pump on all the time at a low level. So in practice, we often talk about different types of radiators. Now, all radiators, convectors essentially, are the same. They have a heat transfer coefficient and they have a surface area, and the heat that transfer is based on those two. The heat transfer coefficient, I won't say is constant, but it's relatively similar from, let's say, 30 degrees Celsius water up to 75. It does drop as the temperature drops. And you get a higher heat transfer coefficient. Just the air is more buoyant and moves past the radiator surfaces more quickly. But we traditionally have sized radiators at what's called a delta T50, or a mean temperature of 70 degrees with a mean temperature of the air of 50 degrees, and therefore a delta T of 50. If you want to achieve a condensing boiler, you need to have a return temperature effectively below 50 to get it to start to condense, and to get all of the efficiency out of a condensing boiler, it needs to be down in the low 40s. So if you have a 55-45 flow and return temperature across a heating system, you will need a relatively large radiator to achieve that. And if you want to get the best out of a heat pump, you really need to be running in the temperature of 40-45 degrees at -3, and then 30-35 degrees as the air temperature gets higher outside. And that's essentially a larger radiator. So 1 kilowatt on the right-hand side, you need, we'll say for an average home that's reasonably well retrofitted, you might have a -3 heat load of 4.5 kilowatts or 5 kilowatts. You might need to buy 3 or 4 or 5 or 6 or 7 of these if it's a very large home. So you can see the sort of difference in price for a high temperature, a medium temperature, and a low temperature radiator. And essentially, if you harness that knowledge and say you're going to spend an extra couple of €100 on radiators, you can get very, very high performance out of a heat pump and pay that back over a couple. So in terms of our approach, I wanted to kind of maybe just cover this in a relatively simple way. There's a lot, this is a very detailed process that takes lots of time, but keep it simple. The first thing we do is we set expectations. So when we talk to homeowners about our retrofits, those homes will end up warm, and we aim to have those homes warm all the time, and not just warm in the morning and evening when you traditionally might be warm with the boiler. So that is quite fundamentally different. So the air temperature might be 20 degrees, but the wall temperature with a constant air temperature will get to that temperature, and therefore you have a higher level of thermal comfort. So when we define and decide and encourage people to do a retrofit, we tell them you're not going to be switching this on and off. It's not a boiler. And that's one of the things that we often hear about myths. Someone puts in a heat pump and then tries to run it like a boiler. It's important to discuss that with the homeowner to say, this is part of the retrofit. We do a technical assessment of the home, and we identify all of the things that are well known in terms of insulation. However, one of the approaches we do is we tackle the air leakage. So we spend quite a bit of clients' money on removing leaks in air, around windows, around doors, particularly if they replace them, they don't always. But we go up into the attic and we lift the attic insulation and we put down air tightness tape on every single ceiling rose and every service penetration. We use foams, we use fillers, we use tapes, we use whatever it is to do that. And obviously if we seal up a house with the aim to get a pressure test up below 5, we average about 3.5, we must design ventilation systems. So we do not go to a home and do a retrofit unless the client is willing to pay for a ventilation system. So that could be heat recovery ventilation. However, the majority, the very vast majority, we would design demand control mechanical extract ventilation. AirEco would be the brand we would use a lot of. We do all the cost-effective fabric upgrades, but if we have a U value of a wall of 0.3, we don't try and get that to 0.15 by spending an extra 20,000 euros or so on external insulation on an existing cavity wall. We don't need that. We replace the radiators where required. Often when you bring down the thermal load of a building, you don't need to replace the radiators, but we size room by room, do the calculations with an engineer, and if we need to change radiators, we do. If the radiators are in very good condition, what we'll often do is move them around the building and take 3 or 4 radiators from downstairs or living rooms and put them in bedrooms and then put bigger ones in the living rooms. We size the domestic hot water with a large tank, a large low temperature coil. So they're typically 2 to 2.5 square meters versus a standard immersion coil would be about 0.8. And the large tank allows the homeowner to take advantage of night radiating for their hot water. We do not put a backup in heat pumps. We size the heat pump to do full load. And if the heat pump comes with a backup supply, we make the installer disable the backup supply, because every time a backup supply is put in, it runs, it kills the COP, and people give out that it's expensive to run. So we make sure we don't do that. We install our program weather compensation. And one really important thing to say is, you give me any house and I can install or design a heat pump that will work very effectively for whatever temperature you wish to have in that house. So it's very possible to do that, and we have done old gentry houses that are, maybe 10 or 12,000 litres of oil per annum, and replace that with cascading heat pumps, very similar to the school you saw, and they run at maybe 20 or 30% of the cost. And it's possible with low temperature, but it's not sensible to heat a barn with any fuel. So if you've got a very leaky building, it's just not sensible to heat it to a high temperature. And what you often find there, those homes, when it gets very cold, they'll have an indoor air temperature of 10, 12, 14 degrees, and everyone huddles around a blazing stove to keep warm. And my approach to that would be fix the energy efficiency of the home, not worry about the heat pump first. So in terms of that design, we use radiators predominantly from a technical design. We use high volume, mass produced cheap steel radiators. Stelrad, Quintherm, there's a number of them out there, Barlow. They're the cheapest heat transfer area per euro invested. The vast majority of them would be twin panel, double finned, 450 or 600 high radiators. We try and mount them on existing radiator pipe spacing to make it really easy for the installer. But we'll measure that pipe spacing, and then we will give them the radiator that is for the design heat load of that building. We'll only replace them if required, and if we don't need to replace them and they're within a couple of percent of the design heat load, we just operate at a slightly higher temperature and save the client some money. However, we almost always, I don't think there's any retrofit that we do anymore, that we don't replace the sitting room or kitchen radiators. And that's just to really ensure that the places where the clients want to be nice and warm, their kitchen and their living room, we can get them to 22 degrees really effectively. And we design for high temperatures like that, particularly in sitting rooms. We size at -3, which is our design winter temperature in Ireland. It obviously varies across the UK for a 40-degree mean water temperature. So that would be a 43 flow and a 37 return. Up until 2019, we sized that for 43 degrees, and the Irish government standard is looking like it will come out at 42.5 degrees mean water temperature. So that's the sort of ballpark you should be at. You can vary that really from 45 to 40 and be relatively sensible. When you do that up at 55, it means your heat pumps are going to be under an awful lot of pressure when it gets cold. We do room by room heat load calculations. We allow a couple of hours a day for domestic hot water with immersion for Legionella backup. And we try and do the demand curve so that really when it's at cold, it flows at 43, returns at 37. And as it gets milder, that drops down. But once we drop down to about 34 degrees at about 7 Celsius outside, we don't drop it any further because there's two things that happen. One, the heat pumps start to cycle, and two, the little nugget I talked earlier about the heat transfer coefficient starts to drop off below 34 degrees, and it's very low at 25. And I would say that we use engineers to design heat pumps, and a lot of the installers who we might have contracted to do stuff, they now start to ask us to do designs that we're maybe not the engineers on, because they know it just works. And there's a reasonable amount of sums that you have to get right. A little tiny bit on radiators, we've kind of covered it a bit, but it's worth nailing this home. So it's important to say, I think this slide is a bit out of date, that should say 20 degrees for heat pumps. And just, I think there's a picture of a triple panel 700 mil high radiator, which you see very commonly on the continent, and particularly where it's cold. And people don't really notice the difference between that and maybe a previous radiator that was there. Like traditionally, particularly in Ireland, we would have had unfinned single panel 700 high radiators of, let's say, 1.4 to 2 meters in most rooms. The odd time we put a fan coil in where there's a space constraint, particularly kitchens, so we use kickboard fan coils. And that's really, they're quite expensive per watt of heat transfer. So we only use them really where we're stuck. And I would say just the vast majority are double panel radiators or even single panel finned radiators. We don't typically go to triple panel unless we have a particularly challenging heat load. This is just some before and after of the first kind of 240 retrofits. We haven't got the afters of the last few. And the red dots are the pre-BER or the energy certificate, and the green dots are the post-energy certificate. I think the average cost, someone was working out there, is about 300 euros per square meter for the retrofits. And I just looked up the UK average home size is 85 square meters, so that would be about 23,000 per UK home on average. Of the homes that we have really detailed and robust data, because it's very hard to monitor homes, we do monitor a lot of homes, but to get really robust data over 12 months or even longer, we were averaging around 26 kilowatt hours per square meter, and that's, in terms of delivered electricity per annum, it's really reasonably good, I think. Now, when we multiply that by primary energy factors, it's probably around an A3 on average in Ireland. Our energy certificates are 67 kilowatt hours per square meter. They do vary. We don't say to people you must have an A or a particular level. We say you must do whatever's sensible to your home, and that usually results in a BER of somewhere between A3 and B2 or B1. Some are in B2 and some are in A2, and we've had a couple of A1s. But to get to the level of A1, you have to do things that I would say are not really cost effective in most homes. So pulling off ceilings and rewiring, replastering, replumbing, and all that sort of stuff, where you have a very, very deep generational retrofit. In terms of cost savings, in Ireland, people would, the roller coaster of oil prices, our heat is made up in Ireland of about 42 or 3% oil, 42 or 3% gas. and about 15% solid fuel. And when we take the cost savings based on oil, which we are predominant market for us, the oil price per kilowatt hour over the last, say, 10 years would have varied from 6 to 12 cents per kilowatt hour net, and we typically average around 4 cents per kilowatt hour net. So we decrease the heat load by around 30 to 40%, and then we cut the remaining 60% in half, or maybe a little bit more depending on the oil price or gas price. I know in the UK gas prices are about 40% cheaper than in Ireland, and that means that the payback versus gas is quite challenging. So I'll talk about some of the optimizations. When we talk about controls, little and often are better than a blast. Allow you to manage down the flow temperature when it gets mild. So we talked a little bit about those curves already. Taking care not to go too far below 34, 35 degrees is about the lowest flow temperature you should get, because otherwise you drop below the minimum capacity. So what I mean by that is your radiators or underfloor heating system might put out 3 kilowatts, but your heat pump might not be able to drop below 5. And once you start to mismatch that the heat pump has to give out more than the radiators are dropping, it starts to switch off and on, and that cycling kills COP and kills the longevity and lifetime. So you want the control system to run steady state for long periods, get the house up to temperature, and let the thermal mass of the house keep the heat pump off for a number of hours. I suppose it's important to say heat pumps are a little bit more finicky, to use a word, than traditional heating systems. So they use fine temperature control to get condensing in the condenser. So they really need to have the pressure and temperature at the right point of the refrigerant. So they need to have accurate temperature measurements of the water returning from the heating system. So when people do what they do on the right hand side there in the picture, and the thermocouple is in contact with the pipe, you get very poor performance. So we would put in pockets in all homes, but even if you don't have a pocket and you use a thermal tape and put insulation over it, it can read reasonably well. So I'm going to talk a little bit around a couple of different myths. And the first one I'm going to talk about is really about heat pumps not being right for cold weather. So I don't know if it happened in the UK, but certainly in Ireland, we all gained a new skill of how to build an igloo back in 2018. That's my children and our igloo that we built in our back garden. So we had 7 days below zero. We had about 300 millimeters of snow, and we were in kind of year 4, start of year 4. So we had 3 years of heat pumps done, and the average temperatures are around -6. Now remember, we designed our heat pumps for -3, so they were well past their design window. We didn't get a single complaint about being cold. We got a lot of positive emails and texts, and I can't believe how warm my house is. Now, I didn't personally have to dig my heat pump out of the snow because there was a snowdrift up against it. So, you know, it was a really good time. So we had a student to monitor heat pump performance. We had a student that summer, and I said, I want you to look at the 2 weeks of that very cold, intense weather, download the data from a pile of houses that we had really robust monitoring, and tell us how they've performed. So this is just one house. The overall COP is the green line on the left-hand side. So it dipped to about 2.3 at the worst time. You'll see the average air temperature. Now, what we did discover afterwards was that average air temperature is about 2 degrees higher than ambient because it's measured inside the heat pump. So the weather station data was down at -6. And at the time when oil was about 80 cents a litre, the blue line would have reflected the COP, where the green line would have needed to drop to be at the same cost of energy as oil. So what happened was, if you think about that, it never got more expensive to run your heat pump than oil. So you were saving all the time, every kilowatt hour. But because it was -6, the net heat demand of the building was significantly higher. So if you take that little gap and you multiply it by a much higher number of kilowatt hours, as it gets colder, our heat pump saved more money, which is really counterintuitive when you think about the laws of physics of a heat pump, but really until it starts to drop to the same line as the cost per kilowatt hour of an oil or gas boiler, it doesn't impact that. Now, if you have more cheap fossil fuels, those numbers change. But I think we'll talk about that in a minute. So then we looked at the worst day for the 16 houses that we had really good data on, and you can see the variation there between 2 and 2.5. This was a -6 day, and I think one of the homes was near the coast and didn't only hit -2. And if we look at the 2 weeks of exceptionally cold weather, they still averaged between 2.5 and 3. So really interesting stuff to see that even when it gets very cold, you still get a reasonably good performance. Now, one thing that's quite important, the Energy Savings Trust survey of air source heat pumps from, I'm guessing, the end of the noughties, showed a 2.2 average seasonal performance factor over the whole year. And our ones were delivering 3.2 over the whole year. So really important to say that they have come on and install them and design them well, and they'll work well. So this is just, we did a detailed study with Limerick Institute of Technology, and we took 20 homes. This was 16 of them that we had robust data, and we optimized them. So we looked at the COP over a year, we'd say over a winter season, October to May, and we noticed that some of them were performing exceptionally well and some of them weren't. And then we optimized them, and we brought the lowest performing one was 3.1, and the highest stayed up at where they were. And the big gap at that bottom side were radiators not being properly balanced, the flow temperature being too low when it gets mild, and the COP falling when it gets mild because the heat pump's recycling. And they were kind of the two critical elements that we found that impacted COP. So the second myth, I'm just conscious of time, I'll keep going. The second myth that really is important to say is backup heaters. So I was doing my MSc in Heriot Watt in Edinburgh, and one of the things I looked at was sizing of heat pumps. So we have 65 homes now done. We've not designed a backup heater in any of them. We have no immersion for space heating. We do have an immersion for Legionella, which can be used for hot water if it did get to -6 or -7 and you needed a little bit of extra capacity. We have some stoves, but our customers complain to us that they waste money on them. But now we tell everyone that all of the other customers who put in stoves and spend a lot of money don't use them because their house is too warm and they can't use them. But if you want to spend 2,000 or 3,000 euros on putting the stove in, it's your choice. And we started to see people say, actually, no, I'll do without a stove. So I looked at the histogram of heat loads for this particular home. It's my own home. And what we found, so I have an 11.5 kilowatt Mitsubishi EcoDan installed. And if we looked at it on a daily basis, so we took the total heat load on a given day for every day of the 3 years of the data I looked at, and 99.6% of days, a 5 kilowatt heat pump would have heated the home. Obviously the one at -6 was the challenge. When we go to 4-hour periods and we break the 3 years into 4-hour periods, 99.8% of those 4-hour periods would have been satisfied with an 8 kilowatt heat pump, which is generally the slightly higher frame size. So it is really important to say that, when you are sizing heat pumps, do not let someone add in piles of factors of safety, because that really destroys the economics. You end up putting in a larger heat pump size, and they don't run as well when they're oversized. So myth number 3, the grid can't cope. So one of the things we also did on that is we looked at the house load, the total house load. This is our electricity DSO, ESB networks, the electricity grid supplier. And they looked at all our homes versus external temperature, and they plotted that chart over 2 years. And they got a really, really closely correlated curve. Anyone knows anything about regression analysis knows that R-squared values of 0.998 are very hard to get. So they found a really, really close curve. Now our grid design standard is 2.5 kilowatts existing. So a heat pump really wouldn't start to put any pressure until it gets to -4, -5. And anyone who knows anything about wires and transformers knows that at -4, -5, wires and transformers have a much higher capacity. So as the temperature gets down, the conductivity goes up. So we really don't have a problem from a design standard. So when I looked at taking the 2.1 kilowatts average at -3 for the 25 million UK homes, it works out at about 52 gigawatts. If I looked at 1 kilowatt per home, because our homes were about 180 square meters, that would be about 25 gigawatt hours electrical and 75 gigawatt hours thermal. There's a typo on that slide. And I looked at some of the data from the UK. So the chart below, the red chart produced in 2014 by Samsung, I'm not sure which university it was, has been thrown around everywhere around heat pumps, saying that this is what the instantaneous heat demand in the UK looks like, and this is what our grid looks like. We can never electrify our heat. Whereas Watson's study said 170 gigawatts total heat would be the entire heat load of the UK. And if we look at a COP of 2.5 or 3 for homes on the basis of that, you've got 68 or 56 gigawatts of heat at -3. So the peak heat load, if it's 170 gigawatts thermal at a COP of 3, that's 56 gigawatts electrical. So the blue line that I have there on the chart is actually the truth versus the red line which was used. So it is really important to say over 30 years, I think the grid will be able to cope with a slight increase in demand. So just, I suppose, a second last slide in terms of summary and takeouts. Well-sized heat pumps and well-designed heat pumps work wonderfully well with retrofits, with existing pipework, with radiators. They do need to be designed, installed and commissioned properly, and competent people is really, really important. I would say that it's best done while doing a whole house retrofit with ventilation and air tightness as key components. I personally feel it's the only feasible way to decarbonize European homes. If you're in a city, district heating is obviously an opportunity. And I would be a big supporter of district heating, particularly where there's waste heat. And I know certainly when you look at the Danish model of probably 50% district heat, 50% heat pumps is where they're going to, and the district heating will eventually have a lot of heat pumps in them. We know that that's the place where the sensible people are going. The alternatives promoted by fossil fuel asset owners, gas grid owners, are just going to lead to additional householder and exchequer costs and poor outcomes all around. And when I see things like we're going to use biogas, or we're going to use hydrogen, or we're going to do all of these things for our gas grid, it is lobbyists, regulatory capturing people. Notwithstanding, we will need industrial biogas, absolutely. Low-grade heat pumps are the only decarbonised answer that I think are there. There's obviously only one opinion. So it's important that we protect people from snake oil and silver bullets. Hybrid heat pumps would be snake oil that I would see. If you take the cost of the hybrid part of it, the oil or gas boiler, and you put that into radiators, you would probably end up with 35 degrees mean water temperature, and any heat pump will work wonderfully well. I think from a policy level in the UK and Ireland, training and upskilling.
Oh dear, I think we might have lost Paul, which is a shame because he was reaching his conclusion. Let's see if we can get him back, because I know we've got lots of questions in the Q&A, and now would be the time for people to add to these as well.
Yeah, and just to say, I've answered a couple of the questions as we've gone along, and hopefully people could see that as well. And also to say, Kate and a couple of other people, if you could stick your questions in the Q&A rather than in the chat, because I'm just going to lose them in the chat.
Yes.
Sorry.
Marianne, do you want to just cover some of the questions you're answering? Things like the energy system in Ireland, the energy rating system and such.
Yeah, so what I can... hopefully everyone saw the answer about coefficient of performance and what that actually means. So that's really just the ratio between the amount of electrical energy you use to run the heat pump and the amount of heat energy you get out of it. So the higher the number, the better, the more efficient it is. The thing about the BER, which Paul mentioned, so that is the Irish equivalent of SAP. It's not something I've looked at in a huge amount of detail. I spend a lot of time looking at SAP and things like PHPP and making comparisons between them. So BER is just the one that, which just stands for Building Energy Rating, is one that I haven't got to yet. Life being a little bit busy.
Sorry, I'm back again. I don't know
what
happened.
Paul?
My internet dropped out. I can't start my video there, I think, if you want.
Right, yes.
Yeah.
Sorry.
Yeah.
I'll let you do that. And also, Paul, if you do drop out again, there's a phone number you can actually dial in. You can dial in on the phone.
Yes.
So yeah.
I'll do that if needs be. There we go. We're back up. I think I only have one slide actually left, which is really good. I'll just share that just because I think it's the second last slide. Yeah, I think I said that. So I'll keep going. So really, I think I'm on the last couple of lines there. So regulations for new build, don't let us dig the hole even deeper. And I think policy signals into the future. The Upper Austrian Energy Agency have launched a campaign saying goodbye oil, adieu oil, and they are telling their entire country that they're switching off their oil boilers in 2035. So get out now. So it's really important, I think, we make those opportunities for people and don't let people invest in the wrong thing. I'm just going to do one little plug. I've done a one-day online heat pump course. It covers some of the slides you've seen have come from that course. It's really aimed at engineers, designers, and main contractors who want to upskill in the area of heat pumps. And there is a best practice guide. The short link is there. I'll drop the two links into the chat box in a couple of minutes. And Superhomes 2.0, the research project that looked at these houses, written by our local university, Limerick Institute of Technology. And there's a lot of detail in that best practice guide, and it's free to download. So that's everything. So hopefully I got across everything that you need. I see there's a few questions coming in.
Yeah.
One thing I wanted to emphasize here is there's some generic questions which I think we can cover, and that's fine, and we'll go through those. There's some very, very specific questions which relate to people's homes. Now, Paul has never seen your home, and I mean, Paul might want to give individual advice, but he may well be very wary about offering specific advice about specific homes. I know we are often on webinars because we haven't seen your homes, we don't know the particularities of them, and if we make recommendations that turn out to be wrong or destructive, then we don't want to be held accountable for for the very best of intentions giving you advice. So just having said that, shall we go through and try and answer the ones that we can? Marianne, I've written down a load, but do you want to highlight some?
Yeah, I think there's some that are probably a bit to do with setting the context. So questions about, are you mainly switching from oil when you're looking at houses, Paul? and is there much peat in that? And related to that, the 65 to 80% saving that you quoted, is that the annual operational cost saving? And what kind of, are people bothered about the paybacks, and what do the paybacks generally look like?
Yeah, okay, it's some really good questions. So the 65 to 80%, I think, is the theoretical savings before one takes comfort back, because most homeowners go from a freezing cold house to a lovely warm house and like it to be warm. So the real cost savings are probably in the region of say 55. I think I don't think less than 50 would be realistic. I think they're above 50 and probably less than 80. Maybe 75 sort of number. Ungrant-aided retrofits of these type would typically have a 15-year to 20-year payback. So they're not, if you're just interested in money, this is not what you do. If you're just interested in money, I think you stay in a cold house. So I think it's important to say that what drives people to come to us, and we've done a lot of data around identifying where and what drives people, and there are three key drivers. There's cost, environment, and comfort. Comfort is the biggest. Environment is probably there with cost, but it's not necessarily cost today. It's people are very concerned about energy prices rising and carbon taxes rising, so that's a big driver. But you know, one of our early homeowners, we asked her to come and do a presentation for contractors of the type of her experience, and she said, if I didn't save any money, this was the best money I've ever spent in my life. Yeah. That for me sold the comfort as the selling point. I see Kate has asked a question there, are you mainly switching from oil, much peat? So we have a parallel scheme called Tipperary Healthy Homes, which is aimed at people in receipt of fuel allowance, so they would get a much higher grant from the state. They would almost all be switching from peat and coal, and our carbon savings per home in those cases are off the charts, maybe 12 or 13 tons a year. I would say we're about 15% solid fuel, maybe 75% oil, and maybe 10% gas. The margin is less in gas, and we have a lot of environmentally minded people coming to us. A lot of the well-known environmentalists would use us to retrofit their house in Ireland. Coefficient of performance is a measure of how much energy is used to move each unit of energy. So you could say another way to look at that is, for each useful amount of heat I get into my house, how many units of energy do I purchase? So if your coefficient of performance is 4, you get 4 units of heat for buying 1 unit of electricity. In terms of recommendations for manufacturers, there's 2 groups of manufacturers. There's European manufacturers, Nibé, and there's loads of other ones like that. And then you've got a lot of the Asian manufacturers, so Samsung, Daikin, Panasonic, Mitsubishi, and so on. We would use a lot of Ecodans. They're very popular. They have a good market share. There's a good backup service. Daikins are also very good. They would probably be the 2 brand leaders in Ireland. I will say honestly, a brilliant heat pump poorly installed is much, much, much worse than a crap heat pump well installed. So it's really, the installation is really important. Backup service is really important. How well they train your installers is really important. Where they, have they got the parts and have they got the competence. So there are things that are more important. However, I would say that Ecodan and Daikin are probably the 2 market leaders in Ireland, rightly so. I would also say that there are probably 3 or 4 manufacturers of compressors in the world. So that's the engine of a heat pump, and that's used by all manufacturers of heat pumps. So there's not a lot of variety in those, but it's important.
Paul, there's a couple of questions on, because obviously you're mostly using air source heat pumps, and there's a couple of questions on combining them with other technologies. So someone's asked about with a PV install, with solar thermal, and also with a PV and diverter setup. Just wondering what your comments were on that.
Yeah, I'll touch on some of those. So I think when it comes to PV, certainly in Ireland and the UK, it's the same from a latitude point of view. We get 60% of our sun, or even 70% of our sun, April, May, June, July, August, September. That's when we don't need any heat, and we get 60% of our heat between 4 coldest winter months, or even 65%. So they don't match up at all. So if you're sizing PV, you size it for your summer loads, and if you're sizing a heat pump, you size it for the winter loads. So while you can ask the question, do they match up? I don't necessarily think they do. However, in the shoulder seasons, we run our heat pumps in the middle of the day, so it uses whatever sun can be there. They can be used along solar thermal panels. I've a heat pump and solar thermal panels and PV and electric cars and all those different types of things. But what I'd say is, the solar PV just comes at a slightly different time. So do we find people pair them with heat pumps and PV? I think we do. And we would install, out of our 265 homes, I would say there's in the region of 60% of them, 65% have PV. That's because people are doing an energy job on their house, and it makes sense. We would obviously suggest to people to use PV diverters if they're putting in PV that they're going to have some spillage. We don't get paid in Ireland. We will next year. However, we do also suggest people, if they do have a battery, that they use the heat pump to absorb the PV and do their heating with the battery and the PV generation. Typically, a heat pump runs at 5 kilowatts for a hot water cycle for a short period of time, 5 kilowatts electrical, and most PV systems wouldn't be able to generate that, so you either have storage or you use a diverter and direct electric.
So I think there were a couple of kind of practical questions, I guess, around what happens if you have a house where you don't have the room for a large hot water cylinder for storage. Have you come across that? Because that's probably, our houses are smaller here, so that's probably more common here than in Tip.
We haven't come across it yet. I have seen the heat battery technology and Sunamp flying around Twitter, and some of the people who are promoting or who like heat pumps like those things as well. I think they obviously would be quite useful for phase change material if you're talking about very limited space. We have not had that issue. I would say we typically have larger houses, and we live in Tipperary, which is outside of the cities, and a lot of our clients don't have that issue.
Yeah, I suppose similarly, you maybe don't have the same issues with noise that might happen here, or is that something that, have you ever had any complaints about noise? Or
we're very careful with noise. So we go into noise quite a bit in the heat pump course that I touch on. Right now, like in the last 2 years, all the manufacturers have brought out low noise devices. And if you're still worried about noise, you put it over grass, so there's a lot less reflective surfaces. You can put baffles, a meter away with a noise absorber. There's loads of ways to manage down noise if you're stuck for noise. However, if you ignore noise and you don't manage it, and you put it on the side of your house, facing your next door neighbor's bedroom window on the side of their house, 2 meters away, you are going to have a huge problem. So that they have to be managed. You do need to worry about the noise level. So you can attenuate and shield them and design them well. So that's, I think that answer.
Yeah, I think that answers that one. And it's that careful design, isn't it? It's designing things properly and thinking things through.
Yeah, I think I'll run through some of the other questions that are here. The majority of these have been funded by the client householder with some form of grants. we have about 20% of them are on affordable warranty programs, who would have got very high 80% or 85% grants as part of different pilots. And yeah, look, it's a fundamental question of governments of how they're going to deal with people who cannot afford retrofits, because we're just making people sick by having them live in poor homes. And I don't have the magic money printer, but that's what we essentially need to think about. I'll explain more about the issues with hybrid heat pump or gas boiler systems. Essentially, you don't need them. So if you think about the additional cost of installing and managing around a hybrid installation, maybe it's €1,000, maybe it's €1,500, that will go a long way to replacing all the radiators, or certainly the ones in living rooms and so on. So the marginal cost of designing a heat pump system to work very well versus sticking a hybrid in, even if you reuse an existing gas boiler, yeah, you might be able to make it a bit cheaper. I just don't see why one would do it. You don't get rid of the carbon. You end up with two systems to run. You end up with standing charges for gas. I don't know what they are in the UK. They're about €120 a year in Ireland. You have to service it additionally to the heat pump, so it's an additional cost. And I just think it's not a smart way to do it. Now, I will say, if it's an extremely large property, if it's a historic property, if it's very difficult to do that and you need to have a peak heat, that is the exception. I think that's a really important thing to say. And we don't need bivalent systems in the UK and Ireland. You may need them in Northern Scotland. I'll say that I'm not entirely sure. Why do we only consider air to water heat pumps and not groundwater? So these are all retrofits, so none of these are new build. And I just don't see the economic justification for digging a well in an existing home and getting a large truck to do that. So that would be why we generally do it. Like, if you consider the marginal gains of a ground source heat pump where the temperature of the ground is above the temperature of the air by a significant amount. So those small number of hours per annum, you might be spending €3,000 to capture that additional COP, and you might end up with a COP of 4.5 or 4.8, versus if you put the same €3,000 into radiators, you'd still have a COP of 4.5 or 4.8, because you'd have massive heat transfer surface areas and be able to run at a very low temperature. So it doesn't necessarily say to me that is a sensible thing to do. Life expectancy of a standard air source heat pump should be able to live for 20 years, I would say. You'd see lots of standard air source heat pumps, air to air, on the continent where they're used for cooling and heating, that are 20, 25 years old. Would I expect to guarantee for 25 years? No, I wouldn't. Would I expect them to be replaced after 15 years? I think unlikely. I would say we'll probably average similar life to a boiler after 20 years. I'll keep going.
Keep going, Paul. Yeah, go on. I think the one that I'm quite interested in as well is the one about low heat loads.
So low heat loads, so 1 to 2 kilowatts. What you do in the main heat pump size seems to be 5 kilowatts. You can get lower heat loads. There are exhaust air heat pumps that are really good for apartments. There's the Nibe have a really good one. There's a couple of others, but be careful with these, because some of them their actual peak heat generation is maybe 1.5 kilowatts, and on average over a day you might use half or two-thirds of a kilowatt for hot water. So some of them are a little bit too low for standard houses, but for apartments there are that type of heat pump. But I would caution that your heat pump needs to be able to generate heat when your house is cold and heat up your house from cold. So I would not go below 5 kilowatts for even a 100 square meter house. I would stay at that. If you're at a 40 square meter apartment, an exhaust air heat pump above your hot water tank in a neatly packaged unit is a great idea. So there, I think there's 2 or 3 questions around that.
Yeah, there were.
Something about non-energy technical barriers, e.g. they're an ugly box outside your home, installation issues.
And also there was a question about culture change within Ireland, I guess. Like how have they gone from, well, I don't know what they were like in Ireland, but certainly here they were kind of oddities and, you know, contraptions, and now getting more widespread understanding.
Okay, there's 2 different questions. Yeah, you can manage if you really don't like the ugly box on your home. I think there maybe is slightly lower barriers in Ireland. I think we're maybe a little bit more flexible in what we stick on the outside of our house. However, you know, some clients have come to us and eventually they got to say, look, I'm just not doing it because I don't want that ugly box on my home. So we certainly have seen that. We also have seen people want to put them and are quite happy to pay for 7 or 8 meters of district heating pipe and put them behind a shed where they can't be seen and they still get the airflow around them. So there are ways to manage around it if people are particularly concerned about that. However, you know, ultimately it is an ugly box. You have to put it somewhere. If you can't put it somewhere out of the way, you have to either deal with it or not do it. And you know, it is one of the challenges. In terms of Ireland in general around the acceptance of heat pumps, there were, if we take, there's kind of three groups of people. There's contractors, installers, and the industry. There's policymakers, policy legislators, and so on. And then there's customers. Obviously, the customers is a much bigger group. We put a very concerted effort into bringing policymakers on board. People who write our building regs have visited our homes and schools across all of the different standards, authorities, government departments. They've all come down and visited and seen and talked to the homeowners and had the homeowners say to them, this is fantastic, I love it. It costs very little to run my home and it's fantastic. And when those voices say those things in that way, policymakers will listen. We show them the data as well, and we make sure that people understand that, you know, that we're not making stuff up and so on. When it comes to the installers, show me the money, in one word.
Mm-hmm.
So if they can make a higher margin on that and you can take out the risk by doing a proper design, they'll work with you. Some installers won't work with us because we have too high standards, but the very vast majority will say, okay, I get it, I know what we need to do, and we'll either choose to do it if they want to or not. And in terms of customers, we put a lot of effort into case studies. So if you look at our website, superhomes.ie, you'll see lots of case studies, you'll see lots of people talking about it. We try and encourage our homeowners to talk about it. We have run a lot of open doors. We've run events where we've got homeowners to come and talk about it. They're quite often environmentalists and are quite happy to lead the way from an environmental point of view and talk about it from that perspective. There are still loads of people who have never even heard of a heat pump, don't know what it is, and we have a long way to go yet. So I think that's an important thing to say.
Paul, just out of interest from our point of view as well, there's a couple of questions on knowing when you're dealing with a competent installer. I just wondered if you wanted to comment a bit on how you've helped develop the supply chain to be able to deliver this work as well.
Yeah, it's a good question. So when people come to us and want to retrofit their home, if they have a contractor on site that might be doing an extension, we will invariably try and work with whichever installer we have, or people who've worked with us in the past. We would send them tenders, and we get a high amount of, we say, repeat business with installers and contractors. But when a contractor comes to us and says, I've never installed a heat pump, I wouldn't be able to, we say, well, that's rubbish. Can you install a boiler? Yeah, I can. Okay, well, you need to learn. This is the course you need to go on. You need to go on the manufacturer's course. You need to talk to the manufacturer and have them guide you and tell you what you need to do and be on site the first time you install. And the manufacturer has to commission the heat pump and show you how to do it and do it with them. And we will help them, and we will say, this is where you put it, that's where you put the, our engineers would if an installer is new, would be very prescriptive in what we do. And then we would visit them during it and make sure that the P2100s, the thermocouples are in the right place, and so on and so forth. So any installer who wishes to do this well can do it well. Not rocket science. Where we have had trouble, we've had trouble with two contractors. One contractor who said it was plumber A, and plumber A disappeared, and it was plumber B who'd never installed one. And they went and did a couple of heat pumps, and it was a disaster because they didn't tell us. And put in somebody who'd never done them before and didn't even try to do it well. And the second one we've had trouble with has been around people who've installed some of the more bespoke European heat pumps with the backup heaters, claim to know everything, but the lad they had balancing the radiators didn't know how to balance radiators, and their fancy, finely tuned heat pump just performed very poorly. So I didn't talk about balancing radiators, but if you don't balance a radiator, you won't get high performance. I'll keep going through the questions if you'd like.
I was going to say, Jonathan, how long have we got?
I'd say another 5 minutes.
Okay, well, there's not that many more, I think. Maybe there's loads more. Buffer vessels, first of all. So buffer vessels are not required where you size radiators sufficiently large that there's enough water in the system or underfloor heating, and they are inverters. You definitely needed them with fixed speed heat pumps a couple of years ago. However, if you have underfloor heating and a small heating system, the package units that are available from most of the manufacturers have a 30 or 50 litre buffer in the bottom of it. And that is not so much a buffer, but it just allows enough flow through. The challenge isn't necessarily a buffer. The challenge is making sure you have enough flow through the heat exchanger. And you don't need therefore a buffer if you have enough flow through the heat exchanger. In my role, we're seeing a lot of indoor air source heat pump units would serve with two pipes, inlet and outlet, essentially using flatted accommodation. I have concerns to the efficiency of these units in comparison to externally located units. I've asked for SCOP to assess further. Yes, critical issue. There's absolutely some crap out there in the market, and there's some great things installed in the wrong place. So that's why I say you need to be really, really careful. They're fine if the heat load is really low, and they're not fine if the heat load is high. And we have seen a bunch of them installed in apartments where the heat load was not low enough. We've seen a bunch of them installed in maybe 80 or 90 square meter homes where, you know, they have a peak heat output of 1.5 kilowatts or 1.8 kilowatts. And when the house is cold, they need 20 kilowatts for 4 hours to heat up the house. And they have a pile of backup heaters, and those backup heaters need to run all the time. I'll keep going if I can.
Oh, Paul, just because there are a couple of questions about refrigerants, one about whether you've had any problems with leaks, and the other about whether you're looking at some of the lower global warming potential refrigerants, so using CO2.
Two good questions. We have not yet had an issue with refrigerant leaks, but I am sure we will. So when you use a monoblock, it's obviously factory sealed. We make sure that anyone who's installing a split is F-gas trained and has their certification and licenses to do that. There may have been leaks that we didn't know about. You know, a client calls the plumber and says the heat pump isn't working, and they realize they have a leak. May have, I don't know. But in terms of low global warming potential, I actually had a master's student do a master's for me last winter on assessing our options in terms of CO2 heat pumps and how they perform. I think propane units are going to be the future. They're not really widely available on the market in Ireland. I think CO2 is really good in new build where your heat load is very small and your hot water load is very high. I think we're going to see a lot of CO2 in commercial hot water applications. CO2 requires a very large delta T to work effectively. You need about 20 degrees to get a really effective condensing because they work supercritical, but they take the heat out when the gas stays as a gas, whereas normal refrigerants, it's the phase change from a gas to a liquid that they extract the heat. Whereas propane is not supercritical, it works like condensing. So that's, I definitely think that's going to be. We've only installed one CO2 heat pump in our finals in a small hot water, mainly hot water load. I'll keep going.
Just one more question then.
No, I don't mind. I'm happy because there's not that many more. I'll try and run through. People want to stay and listen. We have done installations in a terraced house environment. We have small heat pumps, and careful to site them on the grass from a noise. Do they need a gully to run underneath? Yes, you need to have somewhere for the water to run. So you can either pipe it away with standard waste pipe, you can mount it over gravel, or you can have a gully underneath, one of your choice. Does a heat pump need a larger tank than a condensing boiler? Yes and no. It needs a larger water coil. You could use it with a small tank, but generally speaking, all of the tanks are 200 litres to start. Could a hybrid system be justified in a listed building? Yes, it could. I would say that we have done listed buildings with heat pumps, and they're been fantastic. However, if you're not changing the radiators, you can't upgrade the fabric, then a hybrid is probably what you're going to be doing. Tell me how you get to net zero with that house. I don't know. Can you say something about using heat pumps to flex their energy demand? Yeah, so what we did last year as part of the Superhomes 2.0, we trialed a time of use tariff and programmed heat pumps with an innovative tariff from one of our electricity suppliers. It was really interesting. We totally cut out the peak demand from peak times. This is going to be really, really interesting. We're doing another trial with a Manchester company called Homely Energy this year. I think cool. Energy allow that, and they've done some work with them. That's going to be a really interesting space in the next couple of years. What performance warranties do we give? Ian, we don't actually give performance warranties. We have a 7-year guarantee on the equipment. But we don't give performance warranties per se, but we tell people they will achieve a COP of 3 over a year. We install electricity and heat meters if they wish. They cost money, and it's the client's money, so it's up to them. However, I would say that in terms of what we do is if anyone is unhappy, we will stay with them until every issue is rectified, and we keep a bond from the contractor until the homeowner is fully satisfied. And we have had some issues in the past, and we've solved them. Are there systems being implemented to help customers with behaviour change? No, we have decided to stay away from behaviour change with Superhomes. Are heat pump units sensitive to electrical spikes on the supply? Yes and no. European heat pumps have had a little bit more issues on electrical spikes than some of the more robust Japanese issues. So if you're in a very dangerous area from a low voltage, I would suggest you go for one of the more robust Japanese ones that are all single phase, whereas the European ones from Germany and Sweden are often designed as 3 phase, have a better electrical grid that they're used to, and aren't as well tuned. Please comment on the policy of fitting heat flow meters and warranties. I would love to see any installer install their first 10 heat pumps with heat meters and have it linked, so once they can use the heat meter to help them tune. Our heat pump recipients find their electricity bills are higher than before they got their heat pumps. Yes, of course, but they're not spending 1,000 or 2,000 euros on fossil fuels. Have you installed dual heat pumps that also feature cooling? No, we have not.
Less necessary in Tipperary, yeah?
Yeah, it's 14 degrees, it's 16 degrees today and it's warm.
Yeah, no, when we were there in June, it was 17 degrees and I had to explain to Jonathan that was summer, yeah.
I would say, like, there certainly are parts of, I'm seeing that the temperature in London, it's much higher than what we have, and the heat island effect is having an issue. It is something that you have to consider in places where you can't get that kind of cross ventilation and so on. Absolutely, really important. We haven't. In domestic, I have a whole non-residential team that do that all day long, but that's not today's webinar.
Yeah. Yeah, so I think there are 4 questions left. Do you fit heat flow meters as standard in yours then, or is it just something that you've done as part of monitoring?
We used to. So the first, so when the government allowed us claim the cost for those and paid for those, we did a standard. We offer it to every single one of our customers, and we encourage them to do it. And we say, if you do that, it'll be easier for your installer to get them finely tuned. But you know, the package is probably installed €700 or €800, and it's up to customers whether they wish to pay for that. We encourage them to do it.
And then there's a couple about positioning of the heat pump, which is the last one. So does it make sense to have a heat pump on the sunny side of the house if they perform better if the temperatures around them are higher?
Yeah, I think. Yeah, sorry, I was just trying to pull up the the chat that was there. Yes, what's probably more important is airflow than. So if the sunny side of the home is also the windy side of the home, then the answer is yes. I would be quite happy with any heat pump that's in a good airflow. But yeah, absolutely right. The solar earth temperature around the south side of a building is going to be higher, and you'll probably get a couple of % increase in performance. You generally don't get that choice.
Yeah, there's other things that decide where it goes.
Yeah. If you have that choice, then that's yes.
And a last very technical question on pipe diameters and using microbore 10mm pipe, and does that not work due to not enough flow? Do you know if that's true or not? Have you ever used that?
We have had one house with microbore heating, and we were very concerned about getting the flow rate through it. So as far as I know, we replaced the microbore. Yeah, like you don't. The requirement for a huge flow rate is not there. So a typical radiator, 10 degrees delta T and a kilowatt or whatever it is, it's not a huge amount of water flow, maybe 40 or 50 litres an hour. When we did have that question, we weren't at the stage of being able to really understand them as much as we do now. It was very early when we were doing that. So you could use them, but I would put one of my better engineers on it, and I would do design flow calculations on the pipework to make sure. So it does depend on the length of the microbore.
Brilliant.
Fantastic.
That's really helpful. Jonathan, are you going to do a poll now?
Oh, yes, I am, yes. Right.
We did just have, while Jonathan's setting that up, a last question for Paul about whether Tipperary are going to win the All-Ireland this year.
But while Paul considers that, Paul, could you make...
If we have an All-Ireland this year, I think is the question.
Paul, could you make me host? Because I gave you host duties, so it meant I couldn't do the Q&A. It's in the participants. You have to click on my name and make me host.
Someone asked me, Kate. I think someone asked me, do we need high thermal mass in your structure, such as underfloor heating with the tile floor? No, absolutely not. But what will be really interesting is high thermal mass will allow really long periods of load shifting from peak energy prices. So that's just going to be an interesting thing that'll happen. Low thermal mass will allow you shift 3 hours. High thermal mass might get you 4 or 5.
Okay, so I'm just posed would you be more inclined or less inclined to install a heat pump or to recommend one after this? And you've got a few more seconds. And the results, I'll just share them this time. So 66% say they would be more likely to recommend or install one, and 26 fairly likely. No one is not likely. A couple of people don't know. So that's fantastic. I think we should wrap it up there. We had a question about RHI, but I think we're just coming to the end of our time and people are needing to dash off. So I wanted to just get a few things. First thing was to say a massive big virtual round of applause to Paul.
Thank you, Paul. It's really excellent.
And apparently you've answered about 55 questions there, which is a new record.
Yeah, absolute record, and having no open questions at the end of it.
In terms of some last takeaways, if there are householders living in the Greater Manchester area or slightly beyond and interested in heat pump specification and design and installation, get in touch. We can help you through our People Powered Retrofit program. It's a service, so it's costed, but we have some subsidy and we have people involved as well. And we'd love to work with people who are involved with that, who want to spec heat pumps in their homes as part of retrofits. We also, at the bottom of this slide, you can see we're launching, quite excitingly, a heat pump study group, which is for householders and will combine bits of learning and advice. Florence, who's on the call, is going to be one of the experts helping us. Marianne's going to be chipping in with some energy efficiency advice as well. We're going to be taking a group of householders through the advice and thinking about it, planning, and yeah, it's going to be very participatory, and it's going to be a place to learn and share information and progress through. We've got some other webinars coming up. I'm
just posting the...
What's that, Paul?
I'm just posting the link to both our course and the best practice guide.
Fantastic.
So two of them there if anyone wants them.
Yeah. We've got more webinars coming up. Have a look at these. We've got a webinar program website page on our website with all the information. And today's webinar will be posted there tomorrow. Also, a couple of things to highlight. There is a renewable heat incentive consultation out at the moment. Do have a look at that. It closes on the 7th of July, so it's not long, but it's pretty critical to encouraging more adoption of heat pumps here. There's a question in the chat about BEIS, about the government. People were aware of this webinar, and I think one or two people from the department are on the call, so they are listening and are interested, and it'd be great to get people out and looking at installations, as Paul said has happened in Ireland. And just one final thing, if you're an installer or a designer working in the Northwest and you're interested in being part of our program, People Powered Retrofit, do get in touch. And if you're a policymaker and you're interested in our work, again, yeah, do get in touch. So thank you very much. I feel like we've fitted so much into that hour and a half. It's fantastic. Thank you everyone for coming on. Thank you everyone who's participated. As I say, we'll be mailing this out with the links to the course and the guide to everyone who's been on the call this evening. So thanks again. Thanks very much.
Yeah, thank you everyone.
We'll see you later. Paul, you wanted to stay on the chat, on the thing for a chat, didn't you? We'll let people leave, and we can then have a quick chat.
Sure.
Yeah. No, I had to put my headphones on there because I realised that my neighbour's washing machine was going, talking about noise problems.
My kids were having a fight outside the door, and I thought they were going to burst in screaming at each other, so I'm glad that didn't happen too.
Yeah.
See you, Patrick. Talk to you again. I see someone who will talk during the week.
Okay. Jonathan, do you want to quit recording at this point as well?